Hello, fourth grade mathematicians. Your math learning target for today is I can plot numbers on a number line using what I've already learned about fractions, including improper fractions, mixed numbers, and equivalent fractions. So that you can be successful on your exit ticket today, you need to make sure that you watch the entire video, including the lesson at the beginning, where I model what to do, and then doing the practice problem before coming back to the video and comparing it to the work that I show you. And also please notice when I come back to the practice problem, I'm still teaching, so there might be something in that part of the lesson that you're going to need to know to be successful on your exit ticket. And in fact, there is. So make sure you pay also close attention to the part of the lesson when you come back from doing that practice problem. And then at the end of the lesson, of course, there's your exit ticket. Today I want to talk about a very serious thing that happens, that sometimes we see things that we know a different way, and just because there's a lot of words and numbers there, we just assume that we're not going to be able to figure it out. And as we're going to see with this problem, we've already learned in the past few weeks everything that we would need to know to figure all these problems out. The attitude or mindset that we have when we start working on a problem like this, and where we assume that we can do it and we are going to be able to figure it out, and we just need to look at all the information that we're given and read everything maybe more than once until we understand it. That's called a growth mindset. So thinking we're going to be able to do it is called a growth mindset. And I know we've discussed that in both fourth grade classrooms. So here we go. We're going to approach this problem with a growth mindset, with the belief that we are going to be able to figure it out. It says, place each of the following numbers on the number line by plotting the point. Remember, plotting means to draw the point on the number line where it goes. So by plotting the point where each number should go, and then writing the number on the right-hand side of the number line. And then the numbers that we're given are 3/4, 1 1/4, 3, 7/4, 4/4, 12/4, and 11/4. Then we're also given the bonus question, place 1/2 on the number line. So other than the information that we just read, let's look at what other information that we're already given. And the problem said to plot the points that go along with the numbers on a number line. And we're given a number line, and that number line I see is labeled on the left-hand side with whole numbers, with 0, 1, 2, and 3. And we've already learned with number lines that you can figure out how to label each part by looking at how many equal parts each whole is broken into. And so if I look at that between 0 and 1, or even if I did between 1 and 2 and 2 and 3, I can see that each whole is broken into how many equal parts? That's right, it's broken into 4 equal parts, which means that it's broken into fourths, and that our denominator for each fraction or each fractional part of each mixed number is going to be fourths. And so knowing that this number line is broken into fourths, I want you to go ahead and in a second I'm going to ask you to pause the video and copy the number line. And then on the left-hand side, so on this side, go ahead and use what you know to label the number line. So go ahead and pause the video and label the number line. Go ahead. And now that you've done that, check and see if it's the same thing that I did. So we had our first whole broken into 4 equal parts. So after 0, we had 1/4, then 2/4, then 3/4, then 1 whole, then 1 and 1/4, 1 and 2/4, 1 and 3/4, then 2 wholes, then 2 and 1/4, then 2 and 2/4, 2 and 3/4, and 3 wholes. And now that we've labeled the different parts of our number line, some of these numbers and where they should go might be kind of obvious to you. So I'm going to ask you again in a second to pause the video and put a point where you think any of these numbers might go, and then write the number on the right-hand side next to it to show that you're putting that number there. So go ahead and pause the video and try as many as you think that you can, or that you're comfortable with at this point. And then I'm going to go through and talk about each one. So I started with plotting 3/4 on the number line because that was already labeled there, and that's where that would go. Same thing with 1 and 1/4, that was already labeled there, so I plotted 1 and 1/4 on the number line and then wrote it on the right-hand side. And same thing with 3 wholes, because that was already written there, so I plotted 3 wholes and wrote it on the right-hand side of the number line. So now I've crossed the 3 numbers out that I plotted. And other than the bonus question, now I just have to plot 7/4, 4/4, 12/4, and 11/4. And let me just start with 4/4. We've already learned that when you have the same numerator and denominator in a fraction, it's equal to 1 whole. Because whenever you have a fraction broken into a certain number of parts, which is what the denominator tells us, and you have the same number of those parts, which is what the numerator tells us, meaning you have all those equal parts, you have 1 whole. So if we have a whole broken into 4 equal parts and we have all 4 of those parts, we have 1 whole. So if 4/4 equals 1 whole, then we can plot it on our number line next to where we have 1 whole labeled on our number line. And notice I wrote 4/4. I plotted it. I put the point on the number line where the 1 whole is on the left, because 1 whole and 4/4 are equivalent, or in other words, they're the same exact thing. So now I crossed 4/4 out up there because I already plotted it on a number line. And next, I'm going to work with 7/4. Well, we've already learned that when you have a fraction where the numerator is greater than the denominator, it's called an improper fraction, and that it means that the value of the fraction is going to be greater than 1, and that we're going to be able to get at least 1 whole and maybe more out of it. So let's see what we can get out of 7/4. Let's decompose 7/4 into as many wholes, and if it applies, fractional parts as we can. So I see we can get at least 1 whole, or 4/4, out of 7/4. But 4/4 plus what equals 7/4? 4/4 plus 3/4 equals 7/4, because 4 plus 3 equals 7. And that means we can express 7/4 as the mixed number. Well, it's 1 plus 3/4, so the mixed number, that's right, 1 and 3/4. So now we can look for 1 and 3/4 on our number line, and we can write 7/4 next to it, because 7/4 is the same thing, or equivalent to 1 and 3/4. So you can see I plotted the point for 7/4, and I plotted it next to 1 and 3/4, and I wrote 7/4 on the right-hand side. I wrote it as I originally expressed it, or as they originally gave it to us, because that's what they want us to do. And then 1 and 3/4 and 7/4 are the same thing. So now I crossed out 7/4 on the on the number among the numbers that were already given to us because we already plotted it on our number line. And we are going to move on to one of the numbers that we still have left. So let's work with 12 fourths. So again, 12 fourths is an improper fraction. The numerator is greater than the denominator. That means we can get at least one whole out of it. We can decompose it into at least one whole and maybe more. So let's see how many wholes we can get out of 12 fourths. So we got at least one whole out of 12 fourths. What if I added another 4 fourths and made that 8 fourths? So that means on the left-hand side, of the equal sign, or we also call that the equation, we have 12 fourths. And so far on the right-hand side of the equation, we have 8 fourths. And both sides of the equation have to have an equal value. So how many more fourths do we need on the right-hand side to make that the same value as 12 fourths on the left side? So far we have 8 fourths on the right-hand side. 8 fourths plus how many fourths equals 12 fourths? Or 8 plus what is 12? Correct. 8 fourths plus another 4 fourths is 12 fourths. And so now both sides of the equation, both sides of the equal sign match in value. On the left side we have 12 fourths. On the right side we have 4, 8, 12 fourths. So they're equal. And since they're equal, we can't decompose 12 fourths into anything else. We can only decompose it into the 4 fourths plus 4 fourths plus 4 fourths. And each 4 fourths is one whole, so we have 1 whole, 2 wholes, 3 wholes. So 12 fourths equals the whole number 3. And that's right. Sometimes an improper fraction can equal a whole number instead of a mixed number. And here 12 fourths equals the whole number 3. So on our number line, we're going to put 12 fourths next to where we have the point for 3 wholes. And there I've done that. So notice I put a comma after the 3 we already had there, that we already plotted there. And now I've plotted 12 fourths there because 12 fourths is equivalent to 3. It's the same thing. So they go at the same point on the number line. And just to be clear, on the right-hand side, that doesn't say 3 and 12 fourths. It says 3 is equivalent to 3, and it says 12 fourths is equivalent to 3. They're two separate numbers. So now I've plotted 12 fourths on the number line, and I just have one more number that they've asked me to plot on the number line, 11 fourths, and then the bonus question to place, which means plot 1/2 on the number line. So let's work with 11 fourths next. So since 11 fourths is an improper fraction, the numerator is greater than the denominator, I'm going to get or decompose as many wholes as I can out of that. And I was able to get 4 fourths plus 4 fourths is 8 fourths, but I couldn't get another whole, which would have been 4 fourths, 12 fourths, because 11 fourths does not equal 12 fourths. So I was able to get 4 fourths plus 4 fourths is 8 fourths, and then plus another 3 fourths is 11 fourths. And that equals 2 wholes plus 3 fourths, because each 4 fourths is 1 whole. So 1 whole is 2 wholes plus 3 fourths, or in other words, the mixed number 2 and 3 fourths. So 11 fourths is equivalent to or the same as 2 and 3 fourths, which means I can plot 11 fourths on the number line next to 2 and 3 fourths. And there I've done that. 2 and 3 fourths and 11 fourths are the same. They're equivalent, as we just showed. And now I've crossed 11 fourths out. And now we've plotted all 1, 2, 3, 4, 5, 6, 7 numbers that we were originally given on the number line. And that problem ended up being not nearly as hard as we might have just kind of guessed before we really read it, thought about it, and tried it. if we took a growth mindset, which we did, the problem ended up not being too hard. And we just need to learn that lesson, that when we see things in a new way, to take a growth mindset and think about what we already know so that we can solve them. So now on to the bonus question. Dun, dun, dun. It says place 1/2 on the number line, and place is kind of saying the same thing as plot. It means the same thing as plot. Well, it says 1/2, and I know that 1/2 has a denominator of 2, and our number line is broken into fourths, which means that our number line is labeled with denominators of 4, and it's broken into 4 equal parts. So I guess 1/2 just belongs on a number line where each hole is broken into 2 equal parts, and I should just give up, and I really can't put that on this number line, right? I hope you said wrong. Because we know that we can take a fraction with a denominator of 2 and express it as a fraction with a denominator of 4 by finding an equivalent fraction as long as we multiply our original fraction, or the fraction as originally expressed, 1/2, by the same numerator and denominator. And I could see here that if I want to express 1/2 as a fraction with a denominator of 4, I just look at the denominator. 2 times what is 4? That's right, 2 times 2 is 4. So remember, I have to multiply 1/2 by the same numerator and denominator. So if I'm multiplying it by a fraction with a denominator of 2, the numerator also needs to be 2. So 1/2 is equivalent to or equals 2/4. So now I know that since 1/2 and 2/4 are the same, they're equivalent, I can plot 1/2 next to where it says 2/4 on my number line, because they have the same value. They're the same thing. So now here I've done that. 2/4 is equivalent to 1/2. 2/4 is equivalent to 1/2. And I solved the bonus question also. Okay, so now it's time for us to move on to the practice problem. That's the one where you try it by pausing the video after I show you all the information. And then after you try it on your own, you come back and we do it together. And then after this, we'll do our exit ticket, but that's not yet. This is the practice problem. So our practice problem says place each of the following numbers on the number line by plotting the point where each number should go, and then writing the number on the right-hand side of the number line. And the numbers that were given are 5/6, 16/6, 2 4/6, 9/9, 2, the whole number 2, then 6/6, 12/6, and the whole number 1. And remember, if you get more than one number next to a point on the number line, just separate it by commas, just like I have the numbers separated by commas here. And then our bonus question has 3 different numbers that we're supposed to plot. It says plot 30/10, 2/3, and 8/12 on the number line. And what you should notice about this number line is it has labeled 3 holes, 2 holes, 1 hole, and 0. 1 hole and 0. And let's look at how many parts are, actually let's do it from here to here, it'll probably be easier. How many parts are number line, or each, I'm sorry, how many parts each hole is broken into. And you could also see that same thing. This hole is broken into the same number of parts. So you're going to draw a number line from 0 all the way up to 3. Break it into those number of parts. Label each part on the left-hand side. And then you're going to go ahead and do your best to plot these numbers on the number line using the strategies that we've learned today, that we've reviewed today and that we've learned in the past. And then for your bonus question, you're going to think about how you could figure out what the equivalent numbers are for these and plot those on the number line also. So go ahead, pause the video, draw your number line, plot as many of these as you can, and then we're going to come back and review it. Pause the video. So hopefully you labeled your number line so that it was broken into 6, noticing that each whole was broken into 6 parts. So we have 0, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, then 1. I'm just going to kind of show you. So 1, 1 and 1/6, so on, then up to 2. And then this is what from 2 to 3 should have looked like. And notice if I have the bigger lines going across, it's just so I could fit the number. It doesn't change where it is on the number line, or it doesn't change anything. And so I'm not going to waste any time. If it's obvious where something goes on the number line because it's already, that number's already written on the number line, I'm just going to go ahead, plot it on the number line and cross it out. So 5, 6, 2 and 4, 6, the whole number 2 and the whole number 1 were already shown on the number line. And so I crossed those out, and I went ahead and first I plotted them on the number line, and then I crossed them out. I want to go right to 9/9 because I wonder if there's anyone who saw that and used the strategies that we've learned for figuring out what its equivalent is, or if there's some people that saw that denominator of 9 and they're like, the number line's broken into 6 equal parts and I'm just not going to even try that one. So let's look at 9/9. That's an example of where we have the same numerator and denominator in the fractions. So we have a whole broken into 9 equal parts, and we have all 9 parts of that whole, which means we have one whole. So 9/9 equals one whole, and it goes next to one whole on our number line. Let's tackle 16/6 next. So I decomposed that into as many wholes as I could. So I got 16/6 equals 6/6 plus 6/6 is 12/6. And I know to get from 12 to 16, I need another 4/6. So 16/6 equals 2 wholes plus 4/6, or the mixed number 2 and 4/6. And so I plotted it next to 2 and 4/6 on our number line. So next, let's tackle 6/6. Again, here's a situation where we have a fraction with the same numerator and denominator. So we have a whole broken into 6 equal parts. That's what the denominator tells us. The numerator tells us we have all 6 of those parts. So we have one whole. So we plot 6/6 next to one whole, or at the point of one whole on the number line, and 1, 9/9 and 6/6 are all equivalent. They all are equivalent to one whole. So next, or finally, in terms of the regular questions, the ones that aren't bonus questions that we got, we have 12/6. And 12/6 equals 6/6 plus 6/6, or in other words, 1 plus 1, or said another way, 2 wholes. So we're going to plot 12/6 next to 2 wholes on the number line. And there it is, 12/6 is equivalent to 2 wholes. So let's move on to our bonus question. the first part of our bonus question is plot 30/10ths on the number line. Well, we know the number line isn't broken into tenths, it's broken into sixths. So let's see if there's a strategy we could use to figure out where 30/10ths would go on that number line. Let's see, maybe I could decompose 30/10ths into as many wholes as I can, because 30/10ths is an improper fraction. The numerator is greater than the denominator, which means I could get at least one whole out of it. Let's see what I can do. Okay, I was able to decompose 30/10ths into 10/10ths. If I added another whole, another 10/10ths, I'd have 20/10ths. And if I added a third whole, I'd have 30/10ths, which means that both sides of our equation would match, and 30/10ths does equal 10/10ths plus 10/10ths plus 10/10ths. Or in other words, it equals 1 whole plus 1 whole plus 1 whole, or 3 wholes. So we can plot 30/10ths next to 3 wholes on our number line, because 30/10ths is equivalent to 3 wholes. Next, we are asked to plot 2/3 on our number line. Well, again, our number line, each whole is broken into 6 equal parts. So I wonder if I can express 2/3 as a fraction, an equivalent fraction with a denominator of 6. And this is how we've been setting that up. If we want to try to express a fraction that we were originally given as an equivalent fraction, we can set it up that way. So 2/3 times what fraction with the same numerator or denominator equals a fraction with a denominator of 6, which would fit neatly on our number line. And if you figured out that 2/3 is equivalent to 4/6, that's correct. So we're going to plot 2/3 next to 4/6 on the number line, because they're equivalent. They're the same thing. And finally, for our practice problem, we're asked to plot 8/12ths on the number line. And I know our number line's broken into sixths, and this is 12ths. And I wonder if you notice anything about 6 and 12. If we can get from 6 to 12. So I know, like, it was when we talked about 2/3, that we can get from thirds to 6, right? We multiplied 2/3 times 2/2, we got 4/6. But here we have 8/12ths. Think about what you would do. So we could solve this 2 ways, at least 2 ways. We could recognize that we're trying to figure out how many sixths is equivalent to 8/12ths. But since here we're given the fraction that has the larger digit in the denominator, we can set it up like this. How many sixths times blank over blank equals 8/12ths? So here we could still fill in what in the denominator. 6 times what equals 12. 6 times 2 equals 12. And whenever we're multiplying a fraction by another fraction to get an equivalent fraction, we have to be multiplying it by the same numerator and denominator. So in the numerator, we can ask ourselves now, what times 2 equals 8? Well, 4 times 2 equals 8. So 4/6 is equivalent to 8/12ths. And we can plot 8/12ths next to 4/6 on the number line. The other way you could do that is set up your equation like this and use division. So since we are given the fraction 8/12ths, 8/12ths divided by what over what, blank over blank, equals a certain number of sixths, since our number line's broken into sixths. So on the denominator, 12 divided by what equals 6? 12 divided by 2 equals 6. And again, when we're looking to find equivalent fractions, whether we're multiplying the fraction that we were given, originally given, or dividing it, we have to multiply or divide by the same numerator and denominator to get an equivalent fraction. So I place the numerator of 2 there. So 8 divided by 2 in the numerator equals what? 8 divided by 2 equals 4. So 8/12 is equivalent to 4/6. And the reason we could do it this way with multiplication to figure out that 4/6 and 8/12 are equivalent, or this way with division to figure out that 8/12 and 4/6 are equivalent, is because multiplication and division are just the flip sides or opposites of each other. So it works either way. So I went ahead and I plotted 8/12 at the point of 4/6. And now I drew the point because I should draw the point when I plot it. And I want to go back and just clear up one thing that I did. Earlier I wrote, instead of that 2/3 there, I wrote 4/6. After we had figured out that 2/3 and 4/6 were equivalent. But since the fraction I had been given was 2/3, even though I figured out it's equivalent to 4/6, I should have written that 2/3 on the right-hand side. I had written 4/6, but I should have written it as it was originally expressed. Okay, so both 2/3 and 8/12 are equivalent to 4/6. So now we've plotted all of the numbers that we were given on our number line on the right-hand side. And each time that I plotted a fraction or a number that I needed to work with that already wasn't exactly like one of the numbers on the left-hand side, or wasn't written exactly as one of the numbers on the left-hand side of the number line, I showed my work. And since this is a whiteboard, I erased my work after each one, but I'd want to see your work and I wouldn't want you to erase it on your paper, okay? So I want to see all your work when we get to our exit ticket. So now we've finished our practice problem and we're going to move on to our exit ticket. So here we are at your exit ticket. The instructions are the same. Place each of the following numbers on the number line by plotting the point where the number should go and then writing the number on the right side of the number line. The numbers that you're given here are 3/5, 10/5, 1 whole, 20/5, 9/9, 5/5, 2 wholes, 4 wholes, 16/5, 15/5, and 3 1/5. For your bonus question, which I want you to do all of the problems, right? You just can label these as your bonus question problems or numbers. We have 6/2 or 6/2, 12/3, and 4/10. And for your bonus plus question, which I also want you to try, and you should be able to use the same principles or the same method that we used when we were doing the practice problems to solve this problem, is to figure out how 18/10, where that would go on this number line. And here's the number line. It goes all the way from 0 to 1 whole to 2 wholes to 3 wholes to 4 wholes. And here you can see how many equal parts each whole is broken into, and I can just show you this whole. And I'll show you one more whole from 2 wholes to 3 wholes. That whole, how many equal parts that's broken into. So of course your first step would be to finish filling out the number line on the left-hand side, and make sure you probably want to draw yours a little bit taller than mine with bigger spaces so that you can neatly write the numbers on the left-hand side. And then start placing these numbers one by one, and as you place each one and figure out where it goes and show me all your work for each one, after you've placed it, then cross it out. So I should see these numbers all written on your exit ticket with commas next to each other just like that. You should copy it just like that. Then I should see, as you plot each one on the number line, that you put a little line through it to cross it out like we did in the first part of the lesson and during the practice problem. And if you've crossed it out, I should see it on the number line. I should see it plotted on the number line with a point. And I should see any work or all work that you did if it wasn't a number that was already named on the left-hand side of the number line once you've labeled the number line. So if it wasn't already there just as expressed, I should see the work that you did to figure out where it goes. Then I should see the words bonus question and see these three numbers written. And as you figure out where each one goes, I should see that you've crossed them out and that they're plotted on the number line. And on your exit ticket, I should also see the word bonus plus question, or the phrase bonus plus question, and see this number. And when you figure out where it goes on the number line, I should see it plotted on the number line next to its equivalent number. And then you should cross that out. And I should see all work that you did to figure out where it and all these other numbers go. Okay, again, our learning target for today was I can plot numbers on a number line using what I've already learned about fractions, including improper fractions, about mixed numbers, and about equivalent fractions.